Hello everyone, thank you for joining me today in this session. So today in this session we're going to continue from task 5 of this project, see malloc and free. So this task here says we should write a function that concatenates all the arguments of your program, right? So and this is the function prototype. It says we should return null if AC is equals to 0 or AV equals to null. Returns a pointer to a new string or null if it fails. Each argument should be followed by a /n in the new string. So we are to concatenate all arguments of our program. I'm sure you can remember that we've talked about command line argument argc argv, right? We said when we're trying to pass arguments to our program, we need to use them, isn't it? So here, these are serving as what? As our argc and also our argv. Okay, so all what our function should do is to collect all the argument passed to it and it should concatenate it. We've talked about concatenation, right? Just like combining the characters, okay, the strings. So that's just what our program should do. Do you get it? And let's just look at the output here. So these are the arguments here, right? So this is what? Argument 1, argument 2. This one is the file name, right? Or the program name, right? This is what? The first argument, which is going to be stored in index 1 of argv. We've talked about this already. This is in index 2. This will be stored where? Index 3, index 4, 5, 6, 7, like this, right? So when you look at this output here, all the arguments are strings, right? Some of them are characters, just like this one here, characters. But all what I want to tell you here is that they're either a character or a string. And we know that all these strings or characters end with what? A terminating null byte. Isn't it? It ends with what? With a terminating null byte. So the case now is, how many space do we need to allocate to our program to store all these arguments here? Or any other argument passed to our program. It means for us to know the amount of space we need to loop over each and every argument, isn't it? For each argument, we will count the number of string. Just like in this case, this is the first argument, right? I. So I need to count this as how many characters are here. Now I have 1. Then my iteration will move to the next argument, and then this will be in place, right? Will. So I will count how many characters are in will as well. Right? So now I have 5, and then I will move to the next and I will count this as well. So this way I'll be able to get the exact space I need to store all the characters in my argument. Do you get it? Let's just begin writing the code. I'm sure you'll understand what I'm trying to say. So vi paste. So as you can see, I already have my Betty documented to avoid time wastage. So I need a loop. I'm going to need a loop. So I will say int I. I'm going to declare this for my looping. And also, I've already talked about this, that whenever we're going to use malloc, we need a pointer to hold the return value of malloc. And here we are dealing with what? With characters, right? Our arguments are in form of characters. So I'm going to declare a pointer to character and I'm going to call it output, right? So the next thing I need to do is this. I need to know the length, right? I just explained that. I need to know the length of each argument, isn't it? So first thing is I need a loop to loop over the entire argument itself. Let me just write it here. Assuming I have this as argument I. Let's say I, and then, wow, just something like this. Let's say I, and then like, right? And then, for example, you, for instance. So these are the argument passed to the program, right? So this is what? In index 0, right? And the whole of this will be stored in where? Index 1, and this will be in index 2 of what? Sorry, this is in index 1. The file name is going to be in index 0, yeah. So this is index 2, and this is what? Index 3, right? So these are the argument passed to the program. So when you look at this argument here, they are either characters or strings. So it means that each and every argument here ends with what? A terminating null byte. So the space I need to allocate to store these characters here or these strings is I need to count this character, I need to count this, I need to count this, and all the characters here. So it means I need to loop over each argument. For each argument, I need to loop over the characters that are in that argument. So in this case here, I'm going to loop over this. And when I come to this second argument here, that is index 2, I'm going to loop over this, and this. Right? Same applies to this. So I will loop over them and I will be counting the number of characters. Right? So this way I will know the exact amount of memory I need to allocate for my program to store the number of characters in which is passed to the function as argument. So that's just what I need to do. So the first thing I'm going to do here is I will say for I equals to 0, right? Then what should be the condition? I less than AC, because AC is holding what? The argument count, right? We've talked about it when we're talking about the command line argument, isn't it? And then the condition is going to be I plus plus, right? So inside this for loop here, I just explained that for each iteration of this, that is, we know that this for loop we created is going to loop over this argument. The argument here, right, is going to loop over the argument, and this argument also, each of the argument, we want to loop over it as well, because that is how we'll be able to get the exact number of character, right? So I need to create another loop. So let me declare another variable here. Let me call it G. So here inside this, I'm going to say for J equals to 0. So what should be the condition? In this case here, when you look at this, all these arguments are stored in where? AV, right? They are stored in what? Argument vector, isn't it? So what is AV index 1 now? AV index 1 is going to be this character here, right? So what if I change this to index 2? What is index 2? AV index 2 will now target the whole of this string here, right? So what if I say index 2 and then I pass in 0 here? What is this going to print? What am I targeting here? It means go to index 2, which is this index 2, and then in index 2 go to 0th index of index 2. These are all what is in index 2. So go to 0th index of index 2, which is our L. L is in our 0th index. So this is going to print L for me, right? So with this, I'm going to be able to loop over the entire characters that is passed to AV, stored in AV. Okay, I want to know the exact characters, like I said, and I keep on saying, I want to know the exact number of characters. The first loop will loop over the argument, and the second loop will loop over all the characters in each argument. Okay, so here, the condition is going to be what? AV, index I, and then what? Index J, right? So this way I'll be able to target the characters in each index. The I is going to loop over what? Over the argument in ArgV, and then the J is going to loop over the characters in each of the argument. Do you get it? So not equals to terminating not byte. As far as it is not equals to terminating not bytes, then I'll say J plus plus. Okay, so for each argument here, for each loop, we need to increment the value of what? Of count, right? So I need to declare a variable here. Let me call it count, since it's going to hold the value of what? Of the number of characters, total number of characters. Okay, so now here, all I'm going to say here, not count plus plus, this is going to be count equals to 0. I'm just initializing. So here, I will just count plus plus. So what this means is this: for I equals to 0, right? So J, it will check, is I less than AC, assuming the argument count is 3, just like my own case here is 3. So it will jump into this loop, right into the loop. So it will check J equals to 0, or it will initialize J to 0. It will check AV index I index J. This is a two-dimensional array. So what is at AV index I? Our I is 0, don't forget. So what is AV index I? It is what? Our program name, right? Don't forget our program name is here, assuming it is .args here. Sorry about my handwriting. Our program name is there, right? So it is going to loop over what? Over the entire program name, right? Because our I is 0, so it's only going to loop over the 0th index of the argument, right? So when it loops over it and it finds out that it's not the terminating number, it will increment the value of count, right? So this way I will get the total number of characters in my what? In my index 0 of my argument. So I will now increment. So if I increment, what should happen? It will go and also check for this condition again. Now it will move to what? To next index, because I is now 1. So it will loop over the entire element or the characters in index 1. Same applies to this. If I increment, it will move to index 2. It will loop over the entire element of index 2. Do you get it? So that's how it will keep counting. It will keep counting. It will keep counting. Okay. So here, I need to provide a space for the terminating null byte as well. So here I need to say count plus plus as well. Isn't it? Because each of this string here, each of these characters here ends with a terminating null byte. Each of them ends with a terminating null byte. They are argument and they are in string format, so they all end with a terminating null byte. So for after every iteration over this argument here, over the characters, I want to add a space for the terminating null bytes. So that's why I need to add an extra space. That's why I said count plus plus. Okay, so if it loops over the first argument here, at the end it is going to provide a space forward for the terminating byte before incrementing the value of I. If it increments the value of I, it will move to what? To the next index here. After looping over the element of the first index, it will also add its space for the terminating byte before incrementing the value of I, which will take it to the what? To the next index, which is this. Because all of the argument ends with what? A terminating byte. I believe this is clear, right? So what's the next thing we need to do here? So we now have a variable that holds the total number of characters that our argument contains, right? Which is count. So the next thing we need to do is to call on malloc to allocate the exact amount of space for us we need to store all the argument passed as parameter. So here I will say output, because output is the variable or the pointer I declared to hold the return value of malloc. So malloc here I will just say size of what? I'm storing characters, right? So this is going to be size of char, and then times what? Count here is holding what? The exact number of characters, right? So I'll just say count, isn't it? So if I say count here, I need to provide a space also in the memory for the terminating byte, because definitely the concatenated string is also going to end with what? A terminating byte. So all I'm going to do is say +1 here. Okay, so now we need to check if malloc fails, right? So I'll say if output is equals to null, it means malloc fails to allocate memory. Then I will just say return what? We will just return a null. Sorry, right? So what's the next thing we need to do? The next thing we need to do is to begin what? What does the question say? Function that concatenates. So the next thing we need to do is just to do the concatenation, right? So our condition is going to be the same for this, right? It's just that in this case we are not going to be adding this count plus plus or whatever. We just need to do the concatenation. So I'll just say for, why is my condition going to be the same with this? Because don't forget, this is looping over the entire characters and also over the entire argument. It iterates over the entire argument, right? And in each argument it iterates over the entire character. So that's why our loop is going to be exactly like this one here, because we are now concatenating, right? So here I will just say for I equals to 0. So what should be the condition? I less than AC, right? Then I plus plus. So here inside the bracket or inside the for loop, so we are going to create another for loop for j equals to 0, right? So AV index I j, right? Not equals to the terminating byte. Then I will say j plus plus. So inside this for loop here, now I need to do the concatenation. So let me declare an extra variable which I'm going to use for indexing. Here let me call it k, and I'm going to initialize it to 0 here, right? I'm going to initialize to 0 since it is not going to begin in a for loop, right? All right, so what I'm going to do here is I need to store the output, right? I need to store the output. So what I'm going to do here is for each of the argument I iterated over here, I want to store them inside this newly allocated memory, right? So all I need to do is I'll just say output, right? And what index? Index k. I've initialized my k to 0 now because I want to begin concatenation from the first index, right? So I'll say, sorry, instead of saying 0, I'll say k here, right? It's equals to what? It's equals to AV index I index j. So whatever is in index I, which is this, the first argument of AV, and what in index I, whatever is in index j as well. That is, I'm targeting the characters directly. Don't forget, I is targeting what? The argument, while j is targeting the characters in each argument, right? So these are also in index 0, 1, 2, 3, right? So it's targeting the character. So for each of these characters, we want to store them in output k. Do you get it? So that's simply what we are doing here. So after all of this, what do we need to do again? I think we need to increment the value of k. So this has to be in, sorry, I'm just testing. I just hope this should work. Here, just do this. All right, so what do we need to do here? So after all these things, we need to increment the value of k, right? So that for the next iteration, it will move to the next index, right? So here I'll just say k plus plus. So after storing this inside output k, before j increment, k will be incremented. All right, so the next thing we need to do here is, when you look at the question here, the output, for each argument, a new line is printed before another argument, right? A new line is printed before another argument. And this for loop is responsible for looping over each character in the argument. This loop here is responsible for looping over each argument, right? So it means before I increment here, we need to pass a new line, right? We need to pass a new line. So all I'm going to do is I'll just say output. I'll call my what? My new memory, which is output, right? And I will say output at k plus plus, isn't it? Is equals to what? Is equals to the backward slash n. So what this is going to do here is it will increment the value of k from. So what this is going to do here is this. What is the last value of k? Assuming this last character here is stored in index 3 of output, which k is 3, right? So k plus plus, k has been incremented to 4 now, isn't it? So output index 5 will now be equals to what? The backward slash n. So it means for each iteration here, before incrementing the value of I, that is before moving to the next argument of arg v, a new line will be printed. Do you get it? So after all these things, what else do you want to do? I think that should be all right. So we need to just return our what? Our new program name, sorry, new memory name, which is output, pointer to that new location. I think that's okay. No, we need to add the terminating no byte at the end, because output here has already made provision for the terminating no byte. So all I need to do is I'll just call output here at what index? At index k, because k at this point here, at this point, k is now the last index of output. At this point, after all these things here, k will be the last index of output. So at the last index, I want to store the terminating no byte. So I think this should work. So let's test this program and let's see. So before that, let's run Betty 100. Yeah, so Betty is fine. So let's copy the test file. Copy this. So vi 100 in.c. So paste. I think we should find hash I. All right, so let's compile the program. So this paste. All right, so it has been compiled. So let's run the compiled file. Let's just run args. So did you see that I just got args printed because it is the only argument here. So if I should pass something like this, let's see what will happen. So paste here. So did you see that I got args, and then I will show you how great I am. Do you get it? So why am I getting this show you as a single argument? Because when you look at it here, it is enclosed within what? A double quote. So it's going to treat it as a single argument. Do you get it? Assuming we don't have this double quotes here, because it is enclosed within what? Double quotes. Okay, assuming we don't have this double quote here, it is going to split this as well. It is going to consider it as two arguments. So it's going to separate them each on a new line. Okay, so this is simply how to do this. So don't forget, add, commit, and push to your GitHub, and then you can run your checks. So we are going to stop here. Thank you very much. Till we meet in our next session.